The formulas in section 5.3 cover future value of an annuity as well as sinking funds, which is really the same formula, just solved differently. In both cases, we have to pay close attention to the periodic interest rate I. So when you calculate this on your calculator, make sure any rounding that you do is at the end. Any little bit of rounding you do inside of the problem has a chance of causing a major error in the final result, sometimes by hundreds of dollars. So make sure you're really careful with that. The main key with these problems is identifying which formula makes sense. So I'll be focusing on that as I do some of the examples. So in this example, we're saying we deposit $1,000 at the end of each year into an account that earns 6% compounded annually. How much is the account worth at the end of 4 years? And so that may seem like a high interest rate, but you could imagine an investment account certainly would earn this. Stocks historically have earned between 6 and 8% a year on average over the very, very long term. So certainly this is reasonable, maybe not for a bank account. But if we look at this, how do I know what type of formula I should use to determine this value? We're wondering what the value will be in the future after a series of payments. That's exactly what the future value of an annuity finds. So future value of an annuity is always the value in the future after you've made a sequence of payments at regular intervals. And so that formula, which was on the previous screen, I'll go ahead and write it down again for you, is the following. So R represents the periodic payment, I is the periodic interest rate, N is the total number of payments. That depends on how often you're paying into it. And then, again, I is that periodic interest rate like I mentioned before. Okay, so we're going to be putting $1,000 in, so that's going to be my periodic payment. Now, in this case, I is 0.06 over 1, 6% compounded annually. Now, I know I can simplify that, but I'm writing it this way so you can see where the numbers come from. N is going to be 4 times 1 because it's 4 years, and we're putting a payment in once a year, minus 1 divided by, and again, 0.06 over 1. Now, before you go typing this in the calculator, just like I was talking about, make sure you simplify the values. So if I was to simplify this a little bit, there's quite a bit that can be done here. This is actually 1.06 to the fourth minus 1 divided by 0.06. All right? So if you calculate this in your calculator, remember, your calculator will follow order of operations exactly. So make sure you use parentheses appropriately. What I actually do is by steps. So I will calculate 1.06 to the fourth power. Enter, subtract 1. And I get about 0.2625. Divide by 0.06. I didn't round it. I'm leaving it in the calculator, and multiply by 1,000. When I follow those steps and keep everything in the calculator, it makes sure I don't over round somewhere and introduce error. So I end up with the value 4374.62. Now, this may bother you because these are payments over 4 years. And so we only put in $4,000. But remember, it's that interest. So the first payment earns interest for the full time. The second payment earns interest for 1 year less. And the third payment earns interest for a year less than that, etc. So each year, that piece is earning interest for a different amount of time. So this one was with very simple numbers. Let's take a look at one that's a little more realistic. And so at this one, somebody says they stop at a coffee shop every workday, so 20 times a month we'll use as an estimate for that, and they buy a latte, and they pay $4.75 for that. We'll ignore things like tax and all that kind of stuff. So this person studies investments and decides to skip it and invest that amount at the end of each month. You know, before I even do anything, how much would that be at the end of each month? So 20 times a month. 20 times a month at $4.75 would be $95 a month. Okay, I just want to have that ready to go. So she decides to deposit this into an annuity paying 5.7% compounded monthly. What if she does this for 40 years? How much will the annuity be worth, and how much of that is interest? Okay, so again, regular payments at a set interval of time, and you're building up to some value. You're wondering what that value is. That's future value of an annuity again. So once again, that formula will be A equals R times 1 plus I to the n minus 1 divided by I. Okay, so this time the payment is going to be $95 at the end of each month. But the periodic interest rate is 0.057 divided by 12. Now see, again, when you calculate that in a calculator, try to round as little as possible. And in this case, it's 40 years, and she's doing this every month. So this will be 12 times 40. subtract 1, divide, and by 0.057 over 12. So again, you should make sure you can calculate this on your calculator just fine. Again, the way I do it is I do 0.057 divided by 12, then I add the 1, then I take that to the 12 times 40th power, and I get like 9.72 or so. I'm going to subtract 1 from that and divide by 0.057 divided by 12. This essentially gives you a multiplier. And so that's 1,836.64, and I'm going to multiply that times the 95. Everybody has their own way of doing this. When I calculate this, I end up with a future value that's very, very large, 1,700, what is it? Gosh, let me write it all down first. Trying to think about two things at once. So 174,480 and 98 cents. So a very large value. The question is, how much of this is actually interest? So here's the future value. How much did she actually invest? So overall amount invested, she put in $95 every month for 40 years, right? This only comes out to $45,600. So this means the interest earned on that investment over time is actually this amount minus that amount. It's $128,880.98, a huge amount of interest earned over this. And that's because that first $95 earned interest for the full 40 years. The second 95 earned interest for almost the full 40 years. A lot of this money earned interest for a very, very long period of time. So as you can see, if she just put this into an account earning nothing or in her mattress or something, $45,000 versus the investment earning this amount over time. So again, future value, how much is this worth in the future? The other type of problem you'll see in this section is called a sinking fund problem. Sinking fund essentially means that I have some idea that I need to have a set aside amount, a future value amount later on, and I need to know what payments I need to make in order to get to that value. So again, it's the same formula, but what we've done is solve for R. I'll show you one quick example of how this works, and then I think you'll be quite familiar with how to work with this. So let's say a couple knows they're going to start a business in 6 years and they need $10,000. They want to know, okay, what do I need to put aside every quarter in order to have that amount in 6 years if I use an account that earns 6.2% compounded quarterly? So again, we have a future value in mind. That would be that A in the formula. We have a future value in mind. We want to know what payments get there. That uses the sinking fund formula. So that would be R equals AI divided by 1 plus I to the n minus 1. So the future value we have in mind is 10,000. The periodic interest rate is 0.062 divided by 4 because it's quarterly. And then that is divided by this whole value right here. Now the n, 6 years but quarterly, so this will be 6 times 4. So you calculate this, make sure you get the same thing as me. I get $347. Whoops, I don't know what I'm writing. $347.14. Okay, now again, think about it. If they just set that aside in like their mattress or something like that, something earning no interest, $347.14 times 24 payments would only give them $8,331. So the interest here is helping add to that, and that's why you don't simply take the $10,000 and divide it by the number of payments.